Have you ever, like, given an AI a really complex research task, and then you go grab a coffee, come back, and find this beautifully written, highly detailed, just immaculately formatted report that is completely and utterly wrong for what you actually needed?
Oh, yeah. I mean, it is a uniquely frustrating modern experience, right? Like, the formatting looks perfect, the language is super authoritative, but it just entirely missed the underlying intent of your request.
Exactly. Well, welcome to today's deep dive. Today we've got a stack of research centered around a really fascinating new paper, and it introduces something called IDRBench.
Right, which stands for Interactive Deep Research Benchmark.
Yeah, and our mission today is to unpack this massive shift happening in artificial intelligence right now.
Yeah.
Because we were moving away from autonomous AI, where the AI basically just guesses what you want and works entirely alone in a black box, and moving toward interactive AI.
Yeah, exactly. Which is where the system acts more like a collaborative partner, actually pausing to ask you clarifying questions along the way.
And it sounds like a subtle shift on the surface, but the implications for how we work with these systems, and honestly, how companies pay for them, are just profound.
Oh, absolutely. So today, we're going to break down how researchers are actively testing this collaborative ability, which of the current top-tier AI models are actually any good at communicating, and how this is going to fundamentally change the way you interact with software in the near future.
Yeah, because I like to think about the current state of autonomous AI like sending an overly eager, incredibly fast friend to the grocery
Okay, I
store.
love this analogy.
Right. So you shoot them a vague text message that just says, hey, get stuff for dinner. In an autonomous setup, that friend sprints to the store, makes 100 wild assumptions based on that super vague text, and comes back 30 minutes later having spent an absolute fortune on, like, imported caviar and truffle oil.
Which is great, unless you just wanted basic ingredients for tacos.
Exactly. And that is exactly what current AI does.
Yeah, and that's a remarkably accurate analogy for what researchers call the lone wolf flaw in current deep research models. But to really grasp why we need interactive AI, we first have to understand the mechanics of how current deep research systems are actually built and why they fail so spectacularly when faced with real-world ambiguity.
See, I don't fully get how an AI goes that far off the rails, though. I mean, if I give it a prompt, doesn't it just search the web, read a few articles, and summarize what it found?
Well, so that is how the simple chatbots work, yeah. But deep research agents are much more complex. The paper we're looking at builds on what's known as a standard open deep research architecture. It's essentially this four-part pipeline.
Okay, 4 parts. What's the first one?
First, you have the planner, and the planner's job is to take your initial, probably vague prompt and translate it into a structured, formal research brief. It essentially sets the scope.
Got it.
Next, that brief goes to the supervisor. Think of the supervisor as the executive controller. It takes that brief and breaks it down into parallel subtasks.
So wait, the supervisor isn't doing the reading itself, it's just like delegating the work to other parts of the system.
Correct. It delegates to the third component, which are the researchers. These are specialized agents that actually go out and execute those subtasks. They scour the web, scrape the data, evaluate the evidence, and summarize their individual findings.
Wow, okay. And then I assume someone has to staple all those individual findings together at the end.
Yeah, exactly. That is the fourth and final component, the reporter. So once the researchers have gathered enough data, everything is handed over to the reporter, which synthesizes those massive, messy notes into a final, coherent document.
I mean, that sounds like a highly efficient corporate team. But if the structure is that solid, where does the train leave the tracks?
Well, the core problem is that real-world queries from users like you are almost always underspecified. We leave things out. We assume context because we know what we mean in our own heads.
What, like the get stuff for dinner text?
Exactly. If the AI doesn't know your exact intent from the very beginning, that initial planner agent writes a slightly off-target brief. Then, the supervisor breaks that off-target brief into subtasks, and the researchers go spend hours gathering evidence for the wrong thing.
Oh, I see.
Yeah, so by the time the reporter writes the beautiful final document, the errors have compounded over a really long reasoning horizon. The AI has confidently marched miles in the wrong direction.
I have to push back a little here, though. Like, if these frontier AI models are supposedly so incredibly smart, Why can't they just figure out what I mean from context? Why do they need so much hand-holding from the user?
Yeah, that is the exact trap we fall into when thinking about these models. What's fascinating here is that it's not a lack of intelligence, right? It's a lack of telepathy. A highly capable model executing a vague prompt perfectly is still totally useless to you if it's not executing your specific unstated goal.
So intelligence doesn't magically solve ambiguity.
Not at all. In fact, it can actually make it worse. If you ask an autonomous agent for a report on the impact of electric vehicles, a hyper-intelligent AI might give you a flawless, deeply researched economic breakdown of global lithium supply chains.
Right.
But if you were actually preparing a presentation for your local city council on neighborhood grid infrastructure requirements, that global supply chain report is completely useless to you. The raw intelligence of the model just allowed it to run faster and dig deeper in the wrong direction.
Man, yeah. It's aggressively unhelpful. So the obvious fix is that we need the AI to stop, recognize it doesn't have enough information, and just ask the user for clarification.
Exactly.
But that brings up a massive logistical problem for the researchers trying to build this benchmark. Because if you want to measure an AI's ability to ask good questions, how do you do that at scale? You can't have human scientists sitting around all day answering thousands of questions from AI interns.
No, you can't. And that puts researchers in a real bind. And it is exactly where the design of IDRBench becomes incredibly clever, because they had to build the ultimate AI sandbox.
Right.
So they started with a data set of 100 highly detailed, perfectly clear research queries. But obviously, perfect queries don't trigger the need for clarification, so the researchers applied an active ambiguity injection trick.
I love this part. They basically took these perfect prompts and intentionally ruined them.
Yes. They compressed the queries by anywhere from 10% to 90%, actively stripping out the vital context to mimic a real, lazy human prompt.
Give me an example of what that looks like.
Sure. So, for example, they had a highly detailed query asking for a comparison between traditional fintech models, specifically mean variance and black litterman, which are these highly specific mathematical frameworks used to balance risk and reward, versus modern machine learning models for asset allocation.
Okay, very specific.
Right. And the original query explicitly laid out the exact risk constraints the user wanted analyzed.
But a normal person typing quickly into a prompt box probably isn't going to write all that out.
Exactly. So the researchers took that dense prompt and stripped all the specifics out, leaving a super vague request like, what are the main differences between traditional and machine learning models in asset allocation?
Which forces the AI into a state of total uncertainty.
Yes. The AI looks at that and knows it's missing the guardrails. But in the four-part architecture we talked about, the planner, supervisor, researchers, and reporter, there isn't a mechanism to talk back.
Right, so how does IDRBench enable the AI to actually ask about those missing guardrails?
Well, they introduce a new interactive framework with two key modules added to that standard pipeline. First is the evaluator. The evaluator is essentially the gatekeeper. It explicitly calculates the information gain of asking a question against the interruption burden.
Wait, how does it actually calculate that, though? Is it just guessing?
No, it's computing an internal confidence score. So if the AI is 90% sure it knows what you mean based on the prompt, the math tells it to stay quiet and keep working. But if its confidence drops to, say, 40%, the logic dictates that the cost of generating a completely ruined report is far worse than the latency and cognitive load of pausing to bother you.
So it's constantly doing a mathematical cost-benefit analysis on whether or not to interrupt me.
Yes, exactly. And if the evaluator decides the interruption is mathematically worth it, it passes the baton to the questioner module. The questioner formulates the actual inquiry you see on your screen.
Okay.
But the crucial part here is that it is strictly prompted to focus on high-level scope and intent, not trivial technical details. Like, it shouldn't ask you what font you want. It should ask if you care more about risk management or predictive accuracy.
Okay, so the AI has formulated a smart question, but we still have that scaling problem. We are running thousands of tests in this sandbox. Who is typing the answers?
Right. So to solve the human bottleneck, they built a user simulator. They essentially programmed a separate AI to pretend to be you.
See, this is where I get highly skeptical of benchmarks. If an AI is generating the question and another AI is generating the answer, how do you prevent the simulator from just hallucinating totally random preferences and setting the whole research project off a cliff?
It's a very valid concern, and it's why the simulator's design is heavily restricted. The user simulator is anchored to a secret reference document.
What's that?
This document is the ideal outcome, the perfect report that the original unruined prompt would have generated. The simulator uses that document as its absolute source of truth. Furthermore, it is bound by 3 strict rules to make it act like a real human.
Okay, what are the rules?
First, it must keep its answers under 50 words to mimic natural human brevity. We don't write essays back to chatbots.
True.
Second, if the AI gives it a multiple-choice question that completely misses the point, it is instructed to reject the misleading options rather than just blindly picking one.
Oh, that's smart.
Yeah, and third, it actively redirects the AI back to the major focus if the AI starts getting lost in the weeds.
Okay, so it's like a highly disciplined method actor that knows the final script perfectly.
Exactly.
So now that the sandbox is built and functioning, we need a way to keep score. But scoring interactive AI isn't just about grading the final paper, right? Because if I want to answer questions all day, I wouldn't have hired an AI in the first place.
Yeah.
How do the researchers balance the quality of the report against models that are just plain annoying?
That's the big question. Interaction introduces an inherent trade-off. So to measure this, IDRBench evaluates both the benefits, which is the quality of the report, and the costs, which we can basically call the annoyance factor.
Let's look at the benefits first.
Sure. They use report similarity metrics and F1 scores to check if the AI actually hit the right structural and semantic coverage.
Wait, for the non-data scientists listening, what does an F1 score actually measure in this context?
Oh, right. So think of an F1 score as a balance between precision and recall. Precision means the AI isn't hallucinating or making things up. Recall means it isn't leaving out crucial information that was in that secret reference document.
Oh, okay.
And the researchers evaluate this at the sentence level, the paragraph level, and the chunk level.
So it proves the AI didn't just summarize things broadly, but actually nailed the specific details.
Exactly. They also use something called the LLM Aspect Coverage Score, or LLM ACS. For this, they generate 8 to 20 specific intent aspects based on the original query, basically a checklist of things the user wanted to know. And they score the final report on how well it fulfilled those exact bullet points. It directly measures intent alignment.
Okay, so that covers quality.
Yeah.
But then we have the cost side, the annoyance factor.
Right. And they measure this in 2 ways, interaction turns and interaction tokens. Interaction turns measure how many times the system paused to bother you. And to keep things realistic, the researchers hard-capped this. The AI is only allowed a maximum of 1 turn during the initial planning phase, 3 turns during the deep research phase, and 1 turn during the final generation phase.
Okay, that makes sense. And what about interaction tokens? Because I see the word tokens thrown around a lot in AI, and it usually translates directly to money and time.
It absolutely does. A token essentially equals a piece of a word. By measuring interaction tokens, the researchers are tracking how wordy the AI's questions were and how much you or, the simulator had to write back.
This maps perfectly back to managing an intern. Like you want an intern who asks just enough questions to clarify the goals so they do a perfect job. That's a high F1 score.
Right.
But if they are constantly at your desk asking for 500-word explanations every 10 minutes, burning high interaction tokens and turns, you're going to lose your mind, and you might as well have just done the research yourself.
That is the exact dynamic IDRBench quantifies. So with the sandbox built, the rules set, and the scoring system in place, the researchers unleashed 7 state-of-the-art AI models into the benchmark to see who makes the best interactive partner.
And the results here completely flip how we typically think about model superiority, don't they? Because they tested proprietary giants, the corporate black box models like GPT 5.1, Gemini 2.5 Pro, and Claude Sonnet 4.5. And they tested open-weight models like Llama 4 Maverick, DeepSeek V3.2, and Qwen 3235B, where the architecture is more transparent and accessible to the community. What did the data actually show?
Well, the single most universal truth across the entire study is that interaction improves performance for every single model. Across the board, allowing the model to ask questions significantly improved its final score compared to its autonomous lone wolf baseline.
But wait, let me make sure I'm reading this right. Are you saying an open-weight model actually beat GPT 5.1?
It did. And it's the great equalizer effect of this paper. An open-weight model, DeepSeek V3.2, working interactively, actually beat the proprietary, highly expensive GPT 5.1 working autonomously. DeepSeek scored a 78.64 interactively, while autonomous GPT 5.1 scored a 75.59.
Wow, that is wild. It means a model's ability to stop and ask for feedback actually outweighs its intrinsic raw computing capacity.
Yeah. And if we connect this to the bigger picture, it fundamentally changes resource allocation for enterprise companies. You don't necessarily need to pay for the largest, most expensive frontier model to get top-tier results if you pair a highly efficient, smaller open-weight model with a good interactive framework.
And we also see a massive underdog boost, right? Lower capacity models get incredible performance spikes. Like Llama 4 Maverick jumped nearly 11 points in its overall score just by being allowed to ask questions. It went from completely failing the task to producing highly aligned reports.
Exactly. But what is really fascinating is observing the different communication styles or personalities of these models when they are allowed to interact. They all approach the intern problem differently.
Oh, this is great. How so?
Well, for example, Gemini 2.5 Pro acts like the overly anxious intern. It asks a lot of questions, averaging 3.41 interaction turns. It frequently pauses to check in. Now, it gets massive alignment gains from this, but it requires a lot of your time.
So if you're a listener working on like mission-critical legal research or medical summaries, you probably want that anxious Gemini intern. But what if you just want a quick draft and hate being bothered?
Then you want Grok 4.1 Fast. Grok is the hyper-efficient worker. It uses a few and short strategy. It only asks about one question on average, and the questions are very brief, yet it extracts maximum benefit from that sparse feedback. It barely bothers you, but still gets the job done right.
And on the other end of the spectrum, you have Claude Sonnet 4.5 and GPT 5.1. They are the verbose communicators. When they ask a question, they pose long, highly context-rich inquiries, often generating over 250 tokens just for the question itself. They give you a massive paragraph to read before you can even answer.
Which brings us to a critically important economic question, because API calls to these models are not free. Every token generated, every pause to process feedback, and every restart requires computational power.
Right. So what does this mean when the monthly cloud computing bill comes due for a company running thousands of these reports?
The paper highlights massive disparities in the cost of interaction. For Claude Sonnet 4.5, allowing interaction makes it wildly expensive. It adds about $1.23 per report in API costs just to handle the back and forth and the extended reasoning.
Wow.
Yeah, if a company runs 10,000 reports a month, that is a massive line item.
Over $1 extra per report just for the privilege of the AI asking questions.
Exactly. But then look at DeepSeek v3.2. As we noted, it gives you proprietary tier performance when interactive, but the marginal cost of that interaction is just under 4 cents.
The craziest economic finding to me, though, was Qwen 3235B. For Qwen, making it interactive actually saved money. The interactive cost was literally negative $0.006 compared to the autonomous baseline. How does an AI running extra steps to interact with you literally save compute money?
It all comes down to waste. Remember those researcher agents we talked about earlier that scour the web? Web searches cost money. In the autonomous mode, because Qwen was uncertain about the vague prompt, it compensated by doing massive, sprawling web searches trying to cover every possible angle just in case.
Oh, so it just panicked and searched everything.
Yeah, it burned API tokens going down irrelevant rabbit holes. But by pausing and asking the user one clarifying question, it narrowed its focus immediately. Interaction prevented from executing useless web searches. The clarification was literally cheaper than the hallucinated exploration.
That is a brilliant architectural insight. A smart question literally pays for itself by reducing server load. Okay, so we know asking questions makes the report better, we know different models have different personalities, and we know it impacts the bill. But does it matter when the AI asks you the question?
Timing is everything. The researchers conducted a parameter study where they restricted the AI to only ask questions during one specific phase of that 4-part pipeline. They tested interacting only during planning, only during the deep research loop, or only during final generation.
And what was the verdict?
It was remarkably clear. Early intervention is king. Asking questions during the upfront planning phase consistently yielded much larger quality gains than waiting until the generation phase.
Which makes perfect intuitive sense if you think about building a house.
Right.
Like, if the AI, acting as your contractor, asks you to clarify the blueprints before they pour the foundation, that's the planning phase, that question is highly effective. It saves everyone time and materials.
Right, exactly.
But if the contractor waits until the entire house is built, the generation phase, to ask if you actually wanted a second floor, the question is practically useless. The concrete is already dry. The research is already done.
It's a perfect analogy. Resolving ambiguity before the deep research loop begins ensures the subsequent web searches are actually targeted. Now, while the study showed that full lifecycle interaction allowing questions at any phase is generally the best approach overall, there is a catch.
Uh-oh, what's the catch?
The researchers found that some models, like Llama, actually got a bit confused managing frequent multi-turn interactions across different phases. Sometimes its performance actually dropped slightly compared to just asking one good question during planning.
Wait, really? The AI got confused by having too many conversations?
Yes, it proves that continuous dynamic alignment is a distinct cognitive skill. Remembering what was clarified in step 1, keeping that in the context window, and seamlessly applying it to a new question in step 4 requires managing a complex, evolving state of mind. It's a specific skill that these models are still actively mastering.
That is fascinating. So for you listening, what is the ultimate takeaway from all of this? I think the era of the prompt and pray AI is ending. We are moving past the point where the most valuable technical skill is spending an hour writing a flawless 1,000-word master prompt just to make sure the AI doesn't mess up.
Absolutely. The most valuable skill going forward will be knowing how to engage in a dynamic, clarifying dialogue with your tools. You don't always need the most expensive frontier model on the market. As the IDRBench data shows, a cheaper open-weight model that knows how to ask you good questions can easily outperform an isolated supercomputer that assumes it knows everything.
It's a complete shift from dictation to collaboration. And that leaves me with a final provocative thought. We evaluate AI like, in this IDRBench paper, on how well it interacts with us, how well it learns our intent. But as AI systems become more interactive, as they start politely pausing to ask us to clarify our vague requests, they are subtly training us.
That's a really interesting point.
Right, they're forcing us to be clearer, more intentional communicators in our daily lives.
Yeah, that is profound. We are evaluating their communication skills, but they are ultimately mirroring our own ambiguity back to us.
Exactly. In a few years, will we find that working with highly interactive AI hasn't just made our reports better, but has actually fundamentally rewired human patience. Like, if you spend all day having a machine prompt you to clarify your vague instructions, maybe we'll naturally stop sending those vague get stuff for dinner texts to our friends.
Yeah.
Maybe the AI, by learning to be the perfect intern, is actually going to teach us how to be better managers of each other.
I love that.
Something to chew on. Until next time, keep diving deep.